On Wednesday, we started this lesson dealing with inverses of exponential functions, and we drew a couple of different exponential functions, and then we left this one here and drew the inverse of it, and found the inverse to be this particular function, and the domain of that particular function is all greater than 0, the range is all real numbers, and x equals 0 is the asymptote. This type of function, as we said right at the end of class, is called a logarithmic function. When you write a logarithmic function, like with all functions, you have to write it in a proper form. The form of a logarithmic function would be y equals, and this one would be, well, we don't have to write the whole word logarithm, log, and then down here a little 2, and then an x. And we read this log base 2 of x. And a logarithm of base 2 of x looks like this. Has coordinates 1, 0, 2, 1, 4, 2, 8, 3, and so on and so forth. Now understand that with a logarithmic function, just like with any function that you ever have dealt with, if then you were given something along these lines, and then it said x minus, no, let's go x plus 3, that is going to shift your graph which way? If you said left 3, you would be correct because it's with the x, and anytime it's with the x, you have to go the opposite direction. So all of these coordinates then would be 3 to the left. That would be there. That one would be here, and there, and there, and there. And your function would look like this. Now with that type of a function, logarithmic one, the domain would change to all greater than 3. The range would still be all reals, and now our asymptote would be x equals 3. Where it crosses the x-axis would also change, and that would be at a negative 2, 0. And if we had some function like y equals log base 2 of x with no parenthesis, and then a plus 3 here. Now this is not with the x because it's not in parentheses, so that is affecting your y values. So that is going to shift it up 3. So that coordinate would be up 3 and up 3. And so on and so forth, and so it would look like so. And now with this one, because it is shifted up 3, our domain would stay greater than 0. Our range would still be all real numbers. And our asymptote would still be at x equals 0. It would cross the x-axis at a different coordinate. But everything else would stay the same because it's shifted up or down. And so that's what a logarithmic function looks like. So y equals 2 to the x, that is an exponential function. Y equals log base 2 to the x is the inverse of an exponential function, and it's a logarithmic function. All logarithms are inverses of an exponential function, and they look like this. Y equals log base b of x. Just so that you understand, this is considered the base. This value over here, or the one we're trying to find, is like the exponent. And this here is what it equals. So if you were to rewrite a logarithmic function as an exponential, you would say b to the y equals x. Now, if you were asked to graph something like, say, y equals log base 5 of x, if you were going to try to graph it, typically when you're dealing with a function, you would pick values for x. But because this is a logarithmic function, it's easier if you pick values for y. Say 0, 1, 2, 3, and -1 and -2. And so now if you put a 0 in here, you would have this. And then rewriting this, it's going to say 5 to the 0 equals x. And 5 to the 0 power is 1. So in a logarithmic function, 1, 0 is a coordinate when the base is 5. Now then, if you try a 1 and put that here, you would have 5 to the first power equals x. And 5 to the first is 5. When you try 2 here, then you're saying 5 to the second equals x, and x would be 25. At 3, that's 5 to the third, 125, so 125, 3. And then when you go to a -1, 5 to the -1 is 1/5. And so then 5 to the -2 is going to be 1 over 25. And so if you were to graph this, you would have coordinates at 1, 0, 5, 1, 25, 2, 125, which is way off the board, and up at 3, 1/5, -1, 1/25, -2, and so on and so forth. And so it looks like that. One thing that is unfortunate about logarithms is you cannot enter this into most calculators. They do not let you enter with a base of 5. We'll get into some of the things that are on your calculator here in a moment, but this particular one, or with any base other than a couple, you have to figure it out by hand for now, which I know you really love to hear that statement. So then, how do we use logarithms? Here are some examples of things that you can do with them. One would be to evaluate them. Log base 3 of 27. That is saying 3 to some power is equal to 27. And that would be 3. Another example, log base a half of 8. That's saying half to some power is equal to 8. Well, 2 to the third is 8. And since these are reciprocals of each other, this must be then a -3. Then our last example here will be log base 3 of 10. That is saying 3 to what power is 10. Now for this one, unlike these two where you should be able to figure these out without the use of any technology and just using your brain, this one would require some work with the calculator to get to. But before you even having to do that, you should kind of understand this and get a range of numbers. Because 3 to the second is 9, and 3 to the third is 27. just by looking at this and evaluating and taking a guess, we know that this is going to be between the values of 2 and 3. Because 3 to the second is 9, and 3 to the third is 27. And since 9 is closer to 10 than 27 is, it's got to be closer to 2 than it is to 3. Now, what is that exact value? You could sit here and put numbers up here like 2.1 and see if you get 10, but that would be a waste of time. We have better things that we can do later on in this class that we'll talk about, that you can find this answer. For now, though, you would just need to know that it's in the range of 2 to 3. With something like this, and with all of the problems that you're going to get today dealing with this, you should be able to figure those out without the use of a calculator. I do know that when the test comes sometime in January, you will definitely have to do this without a calculator. Now, there are two special types of logarithms that you need to understand. One of them is called a common logarithm. And in a common logarithm, the base is 10. So, it would be something like this. Y equals log base 10 of x. But just so you know, you probably will never see this written like that because it is a common logarithm. Instead, you will see y equals log of x. They will not write a base down here. That base is not 1 if you do not see it. It is 10. So if you were given a question of y equals log of 100, that is saying 10 to what power is equal to 100, which we all know is 2. And we'll go through a couple more examples here in a few moments. But a common logarithm, the base is 10, so it's written this way. The second type of logarithm is a natural logarithm. And a natural logarithm, the base for this is e. Remember, e is that value that is approximately equal to 2.7182 and so on and so forth. So it would be written as this, log base e of x. But because it's a special type, this will never be written. Instead, they will write this one as y equals ln of x. That's an L, that's an N. Natural logarithm, written backwards. So log au naturel. That's how you remember it. The base for it is e. So an example would be y equals ln of e. In this case, it's saying e to what power is equal to e. And that would be 1. Now the reason that these two are special is because they are calculator friendly. There is a button on your calculator that says log. There is a button on your calculator and you've already used it but you use the shift of it because we were dealing with E. You'll see the ln. And so if you have things given to you this way, you can use your calculator to figure out what the answer is. So as an example, if you were given log of 76, that's saying 10 to what power is equal to 76. Without even touching our calculator, we do know that this is going to be between 1 and 2 because 10 to the first power is 10 and 10 to the second is 100. But we can go to our calculator and get an exact answer. All you have to do is type in log 76, hit your equal sign, and you will see that it is approximately equal to 1.8808, and so on. Same thing with ln. You may get a question like ln of 24. And so you just type in ln 24, hit your equal sign, and ln of 24 is approximately equal to 3.1781 if you round to 4 decimal places. It's 05 and stuff after that. And so now that concludes this part of the class. Your substitute will now hand you out the worksheet. And on that worksheet for next year, first day we back from school, you have the left side of the worksheet to deal with. Problems from 16 all the way up to 104. Yes, I know it sounds like a lot, but it really isn't. And you can skip any problem that is a multiple of 3. Now, what are problems that are multiples of 3? Well, that would be like 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on and so forth. Basically, if you can take the number and add the digits together, and if that is divisible by 3, then you don't have to do the problem. So like say, for example, 57, because 5 plus 7 is equal to 12, and 12 is divisible by 3, so 57 is divisible by 3. Have a great break, and we'll see you in January.